Well, today I'm gonna make a recap about the keyword stack in programming, and there's something that I'm gonna remember today, the concept and how to implement it in our environment. So here, there are some questions. What is stack and skill? For the stack and skill, they have the same common that they are all implemented with the array. If we want to implement it with the linked list, we can, but like for the basic one, we implement with the array. And for the stack, uh, we can represent the virtualization of the stack like this, right? It seems like the stack memory, in which when we add the element, it's gonna be stacked up, right? This is A1, A2, A3, F4, right? When we add the element 4, it's going to stack up like that, and then when we add element 5, it's going to stack up right this way. And when we want to remove the element from stack, it's going to remove the last one, right? The element 5. So it's going to remove the element 5 first before, and then the element 4. So this is for the rule of last in first out. This is the principle of the stack. It's the different story with the queue. Uh, for the queue, we can imagine is like this way, similar like the queue. It's which when we add the element, it's gonna add the element from the left to right. This is the element 1. And then if we want to add element 2, it's gonna push the elements to the right. And element 3, it seems like this way. But the only difference with the stack is that it's not when we want to remove the element, it's not go from the last element, the right first, but it's going to go to the first element. Right? This is the difference between the stack and queue. And this principle is called like first in, first out, which means that the first element, right? This one is the first element. It's going to be the first out of this queue. And for the last in, first out, which means that uh, the last element of this stack gonna out of this stack first. So this is the difference and the principle of stack and queue. The use case in the real world applications. I remember. Let's see. For the stack, I think as my memory serves me right, for the stack, like when we for an email notification, right? The last email gonna be the email that's gonna pop up to us first. So we're gonna reach the latest one, right? The latest one gonna be on top. So at we remember the email website, right? The last email gonna pop up at the first, and the second one, the third one, right? The last one gonna be the first that we gonna read. So I think this is the implementation of the stack. And for the queue, what is implementation of queue? Let's see. Honestly, I don't remember. So let's see. To handle tasks. Its operating system. So more. And here this is the example of the queue. I think it's Karamazov, right? Like for example, for the keyboard, when we put the keyword, the memory gonna put the information. Like for example, when we put the KH, right? The K is gonna come first, so it's gonna store it first, right here, and E L L O, right? And for example, if we want to and when the system handle the keyboard, the input of the keyboard, it's gonna handle the first one first and the second and the two. So it's gonna follow like the first elements right here. When it's already handled, it's gonna go to the second one, the third, the fourth, and the last one. It's go for the left to right. It's handled for the left to right. So it is implementation of the queue. It's quite intuitive. Remove all the thing right here. Okay, this is the principle of stack as I mentioned, last in first out principle. And there are some pages API with the stack. Here it have the push, which means that we add the element, right? It means we start up the element. For example, I have like the stack of 5 elements, right? Right now I just call it at the started version, right? We can implement like the dynamic stack by reassign the stack again and again. But right now I just want to demonstrate the static one. So right here I declare like the stack with like 5 space, 1, 2, 3, 4, and 5. It is the first space for this stack. And then when I add an element, it's gonna push up, right, the element into this stack. The element 2, the element 3, right? And when the thing gonna happen is that like when we pop an element, which means that we remove an element, it's gonna remove this element first, right? The top first, and the p stop element without removing, which means that we just come there and print the element without do anything, and it's gonna adjust the size of the stack. So what happened behind the hood is that like right, for the stack, for example, to create this stack I gonna using array, right? This array, the status one, and then I declare this state with like a 5 element, right? With the 5 element, so that this array gonna limit it to 5 element. And then when I add an element for I gonna create the stack class, and then in which I have like an array attribute, and then I have like the size attribute in which I gonna control the size of this stack, right? In the is like when I use the push API, I gonna use like, let's see, and I gonna declare the push API inside the stack. So this push API gonna receive an integer. For example, I for this stack I gonna handle with the integer, but like we can declare like the static like a generic type right here, but for short I just push the integer into this stack and push, right? It's gonna receive an integer, and I call it the data, and then the size in the, alright. So I first declare the size as 5, right? It's gonna set the size in the index. For the index gonna keep track for the size of the stack. For example, when I ask an array, it's gonna ask like I gonna check first, right? I gonna check if the stack size is still greater than an index, I gonna allow it to insert an element, right? I think it must be specifically like -1, because our array gonna run from 0 to index gonna run from 0. So when it's come to 4, it's already like have a 5 elements, so we have to minus by 1 like this, so that the size, the index gonna be, the maximum index gonna be 4. So it's gonna like store like 5 element. And then to add an element, I just easily like array, right? The square root at the bracket with an index, and with an assignment right here, like the data. So done. This is for the push, and the pop is the same, right? It's gonna judge for the pop it's gonna judge if the size is, right, still have like if still it still have a space for um, to put element into the stack. It's going this may wrong. It's gonna check like if like an stack is not empty, it's gonna allow it to remove an element, right? Because it must say that like if a stack don't have any element, why we can score this kind of pop element? So it need to judge first if like an index is not equal to 0, right? And when the index is 0, it means that the all stack it don't have any element inside, so that we just basically uh, return, I think, on inform them the logger or kind thing anyways, but this is the point. And then um, if it's greater, if the index greater than 0, we think I think the greater than 0 is much send more in more much send. And then if the index is greater than 0, we're gonna perform the pop API like let's see, um, the size first gonna like the index minus 1, right? Now the index minus 1, so that we can override. Since we can override, then we don't need to remove it anyway. When we minus the index is 1, it means that like when we want to push an element, the new element, right, the size gonna decrement by 1, so that we can override on this position, right, the position that we already delete. And this is all the thing, right? For insert, for push element, it's like bit O of 1, right, because we don't need to travel through an array, we just add it directly, so it will be a bit of 1. But it's gonna be a different story if we implement it with like the linked list, right? For the linked list, we have to add a new element, right? The structure of the linked list is like this. Right, it is add1, add2, and add3, right? To add a next element, the new element, we have to come through this one, so it's going to be the bit O of n, but like right now I just implement with an array, so it's a bit O of 1. And for the removing, it's still bit O of 1, right? Because it's going to happen immediately, it's don't need to go through the stack or anything, so it's a bit O of 1 basically. And for the pick and top, right, this API just be prints the array at the index and nothing fancy here, I think. And for the empty, we're going to judge with an index, right? If an index is equal to 0, which means that this one is empty, otherwise it's not empty. It's all a thing. And the thing that we notice here is about the static stack and the dynamic stack. For the static stack, it's a physics side may call overflow, right? As you see here is an example, right? When we are because we create our own stack class, so that we can like for the constructor, we're gonna prompt the user input for the size of this stack, and then we initialize for an array attribute inside the stack, so that this array, as we know, that's what an array is. It's the physics side, right? We cannot like add the element of 6, right? If we add like an array as 6, it is not allowed. So to handle it, we have no way. One approved way is that like we're gonna like create another array, right? We create another array and we double the size. It's very up to us, right? Because it's our custom, so that we can like choose the ways to increase the size for the stack. For example, right now the size I want to insert an element of 6, right? Where the push at the push I gonna check again if the size is greater than an index, and I want to create a dynamic stack, so I allow it to reassign my array, so that like if the size is greater in that I gonna create another array, so inside the block. For example, in this block, right, I gonna create another array with like the size double, right? I can choose the array because it's my own stack, so I can choose the array like 1.5 or 1.725 or even 3 4. It's very up to us, but like it's need to meet to the circumstance, right? Sometimes when it double is not like effectively, I guess, because we don't use like this much of the space, and then we use the for loop, right? For the for loop that's increase la 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 la. It's which we gonna like go from the beginning of this array, right? The index, the inner, the index is from equal 0 and less than the size is double. Honestly, it is not necessary. It just be less than the size. Okay, and then e plus plus increment. So we call like real as e equals to array the new array, right? The new array equal to array as e, and then when it go out of an array, we basically just like array as e plus plus equals to new value, right? We insert the new value to an array, and our array automatically increment the size for an array. But for this kind of thing, the bit O for insertion is like bit O of n, right? And for the space, it's also the bit O of n for the space, so it's not effectively. Okay. Yeah. So this is all about the stack. So I'm gonna demonstrate is in the code. Uh, hmm? Oh, what's it? Oh, I can do this more. Anyways, okay. I just want to demonstrate in the Java. Mm. Oh, let's create a new bucket and name it like the stack. And then let's create my own stack like stack collection. And it says stack collection. I'm gonna display first. I'm gonna display an array, right? Oh, I don't know that it allows me to like create an array with no display is the size right here or not, but just create it, and then property size in with the in no, it must be private. False rule of encapsulation. All the attribute is private, and the only way to get the element is using the getter and setter, like the size. Okay, and then private in for the index, right? As we call the constructor. Okay, it's informing an error right here. Right, it's have like private accessory. I just try to release it to the public. It's still not allowed it. Right, for this right, we have to display the size of it right here, so the customer will don't allow us to provide the size. How it can handle it? Let's see. Right, basically, I have to display the size of the stack of an array right here. I can escalate noon and then escalate the size first. Okay, I'm gonna ask my friend how to handle it. How to handle it. Uncheck it. Suppress warning. Oh, what is that? I still don't understand this kind of thing. Right here we're using the reflection of an array, and we call the reflection library for an array which create a new instance for the class. What is this though? This is the generous type, which means that it can be anything. Okay. No. Like I can score it with like an array. Okay. Oh, it's arrived right now. I think I forgot to push the the practice right here. Right now it allows me to do something like that. I think it's gonna be okay. Okay. First, I create some supported API, right? Because sometimes we need to just like the stack is empty or the stack is full or not, so we can. So it's gonna be nicer if we create some supported API. Right. For first, like we're gonna like just empty. I think AI wanna success me do something, right? Return if the index is less than equal -1. I'm gonna initialize it with the euro private static. No, it don't need to be static because I just create it one time, so it don't necessary to create a static. Just for if it's with euro, it's must saying if full with the -1. That's right. And then I gonna like decide for to push the element. Oh, AI says to me, I should tap on this tab. Right, public right for any API. It's choose to use like the boolean rather than the void because we really want to get something. Right, when we score it, we really need something. Otherwise, we can like using some logger message, but it would be nicer if we use the boolean to do anything. Because right now, I just use voice push t data, which means that the array can store any type of data. Okay, if right first case the S case, if it's full, right, as I mentioned, if it's full, it's that it's full and we cannot uh, like start up the element. Otherwise we add up the element. Right here it's still like the pre increment, so it's gonna increment first and then put in that. But I think why we have to like cut it to, okay, just cut it because it's like general style, so we have to cut it in some way. I still don't know it right now, it's going to be some error or not, but just there is row for removing an element in the stack is kind of easy. We just decrease the index and then we override. It's much more easy with like for the queue, right? Is which we have to shift the element from the right to left, so it's going to take like a bit over one for time for sure, but we can handle it with like the circular queue. So it's going to do it later. Right now, just be the push and the pop API. I think this is all enough, right? For the B stop, it's a bit kind of same, right? Rather than do something like the logic right here, we just like print this out. So for saving time, I just do it like this way, and then we're gonna test it in the let's see where in my main to run the code. Okay, it's here, it's here. I honestly believe that the AI on success may do something. I just like start integer, right? Right, because we're using like the dap casting right here, we're using the general style right here, right? It's receive one argument as the general style. So to display the collections, we have to use to display the class. We have to like tell the system which is going to be this D. Right, it's public. Okay, everything is right. Push 1, push 2, push 3, push 4, push 5. Oh, it's odd enough. I forgot about the display function. For display, we just go over it, right? Display an image, we just use a for loop, right? It's already sets me here. Yeah. Nice. We don't need to do anything. Just print now. Display. Let's see. Let's see. What is tell me? What happened? Cannot cast class SQL right. Oh, it's cannot casting. How to handle it? Right here, this is about generate type. Generate type. How to handle it? Ask my friend. Hmm? Hmm. Anything happen? What the fuck is that? Force data. Why? What's happened with this though? And for this, just for empty, right? It's better like for just for -1. Oh no. I think it is better me to like push an array. Hmm? Hmm. I don't know. Just ask my friend Karok. Oh, it's taking a lot of time for implementing this kind of thing. Let's read the explanations right here. For is right to T, see the general stack implementation. The R is right in the right type for stack implementation. Mm-hmm. Right is the lines with new just as the new right side. Oh wow, it's allowed right here. For example, if I push like start at 4. Mm-hmm. Ah, because I using like pre excrement, so that's like for the red, and that is gonna excrement by 1. Yeah, it makes sense. And for the dynamics, I think like if it's full, it's gonna reassign this block. Mm. double the size. Oh, we have like this ABI. This curve ABI is, I think it's used in the stream. It's called convenient, but let's see. Let's figure out this ABI. This is current array, copy and array. This is like where it's gonna be copy, and this is the location. Okay, it start from 0 from this one, and it's gonna insert from 0 to the side for the new stack. Hmm. Oh, okay, it's allowed right now. Right for this is a out over it's printed 2 times. 1 2 3 4 5 1 2 3 4 5 6. Right, it's played 2 times for this one. Let's see the logic. Right, I double the size for the start, and then I create a new one. It's great. And then I use the for loop. Oh, here I L. I just add this normally. Right, I should show the L block right here. Oh, no, it still be the same. It's still right here. Right, it's works well. I think. Right, we just reassign the size of the collection. Anyway, you see, like a lot of problems come up when like we write the real code rather than just for the theoretical part. For the theoretical part, it's kind of easy. But like the problem going to be happens like when we actually write the code, it's going to be touch me a lot of time if I figure out this kind of thing. But the AI support me, right? Let's see for this annotation, it's even checking, so that like it's gonna not warning any error right here. I think if we remove, it's gonna have an error inside this block. Okay, this is right, and then oh, this is our thing. First, we cannot put an array right here because we work it with generic. If we pass an array, it means that like we exactly pass an array, so it's no generate anytime more. Okay, I think that is the point in some way. I think I still not understand it 100%. But it's all about the start and skill, so not figure out more about the generic. And for the queue, the definition, first in, first out, right? The first element is gonna pop out at 1, at 2, at 3, at 4. The element is gonna be left out. Right? When we add elements, we're gonna add at the rear. Right? The rear right here. For example, I display like an queue with the file space for the started version. It seems like the stack, right? That I even on the right, so that like it has the physics side right here. So when I add elements, it's gonna add at the rear. And when I dequeue, I'm gonna remove at the first, right? And how to remove is like that. We're gonna shift the element. We're not like remove it like uh, we just remove it by shifting the elements from the left, from the right to left, right? Boom, 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 boom. Just gonna elements gonna remove it, and it's gonna as I mentioned earlier, it's gonna take like bit O of n for removing the time complexity, and for the space it's gonna bit no. Oh, it don't need for like for the bit O it's a bit of 1 for space because it's not cost to create any more space. Okay, and for a bit it's just like similar to inskew and diskew, but it's not remove or add, it's just like print out the element is empty. It can be seen like support function. Okay, it's all the point. The dynamic version is standard version. It's similar to stack. So right now, I demonstrate in the code the real problem gonna happen right here, right? Not about the theoretical part. Let's create a new project and let's create the queue. And inside the queue, you're gonna create a Java class queue collection. And inside the collection, I'm gonna create the general type like private t. Right here is create a general collection, right, with the square root. And to using the t keywords, I need to display the t with the diamonds right here, and scroll at the q and front. Okay, that's right. Rear, like this one I'm gonna talk later. Right now it's honestly don't need to care about it. We just need to like scale the size and the index. I think the front and the rear is for the circular queue, but just leave it right there right now. And similarly to the stack, let's see. Okay, this other thing we initialize with an index with the euro, and for the constructor we create, and to make it not like suppression to running and untrack, so it's not running us anytime more. And we want to explore some simple APIs like just for empty. If it's empty, it's like when the index is equal or less than 0. And check if the full is full, like when the index is what size. This is the support API. And then there is some logic API right here, like and queue element to the queue, like when we add the element to the queue. No, it's not like this dynamic version, right? Oh, AI is so smart. It's already know, it's learned maybe from the previous stack, right? Like when you just add elements by using like this way, that's like when we add an element is in queue is like, because especially it's on the right, so it's just add element from the left to the right. Okay, and this is also like the dynamic version, right? If we remove this one, it's not the dynamic version because we not reassign or array, right? So we not reassign this one. And another API is like in queue, this queue elements from the queue. it's not successing me anything, so I have to write by myself. Oh no, not set the queue. This queue would mean that I gonna remove the first element in the beginning tab. Oh, it's easy to use the tab, right? You're gonna just first empty. If it's empty, it's gonna like print the logger message first and return. Otherwise, it's gonna shift elements from the left to right, right? If you see here, like from one, it shift the element and remove. Honestly, we don't need to do this like insert to the null, but it's nicer if we do it. It's like more clean code, I guess. I want to really do a something like that for the queue, right? 1 2 3 4 5. Suppose I declare a queue with the 5 element, A1, A2, A3, A4, A5, and this is the index 1 2 3 4 5, right? When I insert element of index 0, as you see here from the implementation, it's gonna add the index plus 1, right? It means that like for the elements as E1, the elements 1 Q as the element 1, like at this position, it's gonna assert with the new value. The value gonna touch it from this one, right? The Q at 0 minus 1. It means it's at the position, and then the follow just go, right? It's go like 5 times, I guess. Right, the Q length. No, right here. It go like that's right, like the 5 times, the n time, right? The size of an array. Of an index, right? Because it interact with an index. Okay, I think this is the whole point, right? To avoid like shifting an element, there are another implementation is like the circular queue in Squid, like we don't have like the last or the first element, right? The A1, A2, A3, F4, F5, right? It's going this part, and we use another way to keep track the element, like another reference. We use like we display another 2 elements. The first is the first, and another is n, right? As you see, like it recommend me to use something. Right, the front and the rear to keep track of, and the different is that like you are using the modulus to add an element or remove elements, so like something like that, right? For example, I have an array of 5, the size is 5, right? Before it, and my current element is right now, for example, for the first and n as beginning the I just want to remove this E anyway. I want to store it again. Right, at the beginning, the first and the end is the same, right? When for example, I insert like is one with the value of 1, right? Right now, the first and the end is the same. But like when I add the new element, like I set the element 2 is equal to 2, the n index gonna move into this one. So we're gonna know the first and the end of the element, right? And the fancy thing gonna happen is that like when I want, for example, I just assert like a new element, right here is like 2. I search with the value of 2, and for example, I want to remove an element. The only thing happen is that we just remove the n is right now moving to here, and the front variable gonna move in here, right? Because right now this is our front element and the end is right here. So it's gonna move in like this way, and then when we print out the element, right now it's still like have a 3 small space to add, right? So for example, if I want to add an element, the next element is 4, the end gonna move in here, and when I add the element 5 equal to 5, the element's gonna come to 5 right here. And right now I can still add some elements right here, right? But like for the index, for example, I just declare the maximum size of this one is 5, so the index is right now it's already a 5. I cannot like add an element like q assist, right? I cannot add an element, not the elements. I think the index right now is 6, right? No, it's 5. It's definitely 5. Right now I cannot like add as the element assist. So to handle it, I using the modulus, right? When I want, and this is the index, right? In E, when we push an element, when we add an element into the queue, an index gonna increment by 1, right? So right now the index, and if an because the front and E I gonna do another like check, right? If like I still the size is still 4 and I still add one element, the index gonna do something like that, like index equal for index modulus by the size at the maximum size. I call it length. Let's create another length. This is like the physics size for this one, and the size is like the difference between the end and the front, right? Right now it's the difference is 4 and the size is 5, the length is 5, but the maximum element is 5 and the size is 4, and the index is right now is still at 5. So to add an element we modulus by the length, right? 0 and 5 modulus by 5 is 0, right? Because it's one an index right now, the index for elements 1 is 0, right? So for an index it's equal 0, so it's going to insert the first elements right here, and then we increment for the size. We the size is increment to 5. So right now the size is 5. So if the size is 5, we cannot like add element anytime more because it is a started version, but we already implement like the beauty of we already mean like the dynamic queue, so that we don't need to worry about the size. But the different is like we can remove an element without shifting an element. We can remove it directly. You just remove it at the front, and only thing gonna take care for it. We just moving the reference of the front to the next element. So that's the other thing. So just implement it right for the end queue. We create the front and rear. Let's see for the for loop. We're gonna assert the rear, right? The rear right now is an index. Rear is word index, and before we assert it, I think we have to modulus for or we can manipulate. We don't need to declare the length the len variable to keep track the size of this cube. We can like using like the front minus rear as rear. No, I think we still have to do so. I display another variable like private int len capacity, right? It's only must send more with the word capacity, because I want dynamically. I don't need to display it like this way. And when I initialize, I push like the capacity return the size, because right now the size is like the difference between the front and the rear. And for the capacity, this capacity equal this capacity, and I square with the capacity. It's much more sense right now, and the Q the rear, and like right now the size is different, so size +1 it means that like the size from the start, the front and the rear, right, are different. So I'm gonna rename it for the name might be like long, but it's more intuitive to write it like this way, right? When we insert a new element, the rear gonna be equal to an index, and then the different plus by 1, and before insert, like the index must be modulus by 1, by 2, modulus by 2. And for the Q, when we're removing the thing, we don't need to use the for loop anytime more, but like the font also needs to modulate by 2, and the difference the front and rear is like less than 1. Let's see, I miss anything. For the rear, because we're using the pre-increment, so it must be the index minus 1, the rear equals to -1. The difference between the rear and front. And we need to check like because we already using that dynamics first, so we don't need to take care about like when the size is full. I think everything is good though. Let's just run it. Comment these things out. we initialize with the front, and the condition of the front is different. The I right, it's different with the rear because the rear is the last element. So I think it's we still need to like print the last element. Was not allows me. Let's go from the front. Okay, it's just it's cross right there. I don't know why not allow worries to like. Let's see if it's missed any information or not. Something's wrong. This one okay, this one okay, this one okay. The only thing is for the NQ, for the capacity, it's gonna double, and then okay, this good though. And we're gonna insert a new element. Front. Front equal euro, while we access to euro right here. Oh right, that's right. Because like when we reassign, we don't need to keep track the front and rear like this. Anytime we like rearray, we need to change like the front and rear of the queue and the capacity also. So everything gonna like start again, right? I think like this. For example, for this one, right, when it's already full and the font right now, For example, the end is right here and the front is right here. Like the front is like at the index of 2, index 1, right? And this one is index 0. The end is at the index 0 and the front, the rear at the index 1 at 0 and the front at the index 1. So if we want to create, when we create another tree, queue with the 10 element, and 1 2 3 4 5 6 7 8 9 10, right? We're gonna like assert the element from the front, as you see, the master right here, the front is -1. From the queue to the end. Alright, the reset the front, we're gonna insert like from the index 0, like this, right? At the index 0, this one is index 0, right? New array at index 0 is equal to a normal queue, the previous one, like at the front, right? The front right now is 1. It's we modulus by 2. Why we like increments by 1 right here, R. We just like increment the index for the front. Just moving right down, like create another dummy. Oh, why it's like increments by 1 right here? The goal is to copy or resist the elements from old array. Choose new. Oh yeah, that's right. Because like for the size, for example, the size is like just percent. Why the code is right. Right here, right? Because like for the index is gonna run from like the 0 to the size -1. So that's like to insert the last elements, we're gonna like work minus plus with an I. It's modulus by the length. copy everything. As for the DQ, right, first is just like the font in Noon, and then we increment the font and small reduce by the opacity and reduce the size. Right, the size is different between the front and the rear. It's just with a different thing. Right, it fools when the size is equal to capacity. This is the correct implementation of the code. Right, for the DQ, the logic is kind of easy to understand. For the EQ, there is some thing that, let's see, for the front it's monitored by 2, and for the Q lane let's demonstrate with the drawing. For example, right now the front is right here and it's right here. Right, the front is equal to 2812. The front is as the index of 1 minus y is 0. Once minus I is like at the index of 1. Right, it's right now here and it's equal to 2, and it's like when e is 2, e and then as the e is 1, the element fronts right now moving to, let's see, I think I think the main point that the front is not moving, right, because we still keep track of the front. Okay, so that we just leave it there, so the front is always there, we're not changing. So if we want not to plus with an I, we can do something different. Let's see. Yeah, nothing. Plus ones, right? Right, it's remove the first element, and the first element is 1. Everything look cool, and because it is dynamic and Q, so that we can like right, nothing error happened, which means that it's successfully inserted into an array into queue. But the 7 elements right here, it runs from 2 to the 7. Okay, it's look right, everything there.